So in this problem, we have a word problem here. We're looking for the decay rate. What I'm going to do is I'm going to set up my entire equation, then we'll talk about the decay rate. So if Zach had $20,000 in his savings account, really what we're looking for here, that says that's our starting value. Okay, so that's what we're beginning to work with. And as we remember, in y equals ab to the x, that's going to be our a value. So we're going to put 20,000 right here in our equation. Then it says he spends 40% of his money every year. When we write our equation, we're not looking for how much he spends. We're looking for how much he maintains. So out of 100% of his money, he spends 40% of it every year. That leaves him with 60% of his money each time. Now, if we turn these all into decimals, okay, like percents actually are, if we're taking 1 minus 0.4, he's going to be left with 0.6. So what we're going to do here is, in our equation, the amount he maintains, we're going to put as 0.6. And when we talked about decay rate earlier, we talked about exponential decay. The number for b has to be smaller than 1. So this does fit that qualification. We're going to take 20,000 times 0.6 to the x. That's actually going to be our equation. Now, if we're looking for how much does his account decay by every time, well, that answer is right here. And that just means we'd have to convert that to 0.4. That would be our decay rate. But if we're looking for our growth factor right here, we're going to keep 0.6 as our equation. So when writing this equation, the important numbers are 0.4, which he's spending, 0.6, which he maintains, and if you understand the connection between those, then you'll be in sweet shape.